introduce you to Dr. Merav Ben-David. She's been at the University of Wyoming since 2000, is that correct? So 16 years. As she said a little while ago, she's from Israel. She did her bachelor's degree at Tel Aviv University and her master's at the same university. Of course, as you'll listen to her, she graduated cum laude, a bright woman. She did her PhD at the University of Alaska at Fairbanks. And I got the opportunity to last night to learn a little bit about why she was interested in ending up in some northern region like Alaska. In 2012, Dr. Ben-David received the Barrett Hamilton Distinguished Ecologist Award from the University of Manitoba for her contributions to polar bear conservation. And she has also worked as a safari tour guide in Kenya for 5 years before she relocated to Alaska. As we were coming up here yesterday, I don't know how we got on this, talking about our jobs in college. And I think Dr. Ben-David probably had the most unusual. She was a zookeeper, so she's been at this for a while, interacting with animals. And I told her I was going to give her extra gold stars for being a speaker today, because first she sent me her title of her presentation as she was leaving for Ecuador. And then the abstract that you see in the poster she sent from her phone on a boat, right? Off the Galapagos Islands. So I think that's real dedication to wanting to make sure that we got everything organized for this Saturday University. Today, Dr. Ben-David is going to talk about polar bears and climate change, walking on a faster treadmill. So let's welcome Dr. Merav Ben-David. Thank you.
I'm going to tell you today about the work I've been doing since 2000 with several colleagues on polar bears and climate change. And I know from talking to many people in many scenarios and many presentations, various ages of people, that we have, or many of us have the perception that the Arctic sea ice is basically a solid ice expanse, unbroken and flat, something that you need an icebreaker to break through to get from one spot to another. But this is very far from reality. The Arctic sea ice is composed of big plates of ice, or sometimes small plates of ice, that constantly move and are carried around on ocean currents, tides, and are driven by winds. And unfortunately, this didn't embed properly into the presentation, so we'll just view this video on the screen directly. Okay, so here we are getting from Wyoming to the Arctic Ocean. We are looking at the globe from the North Pole. In white is older ice. As you get closer to blue, it's new ice, 1 year or 2 years and less. And this is how the ice is moved. These are weekly ice images showing you the ice is moving constantly. This is going through time. At this point, don't worry about that. We'll get to see this video again later. But what I wanted you to look at particularly is that the ice is moving. So pick a white spot and follow it around, and you see that the ice is constantly moving. If you concentrate on the northern coast of Alaska, where I do most of my work, you see that the ice is moving from east to west. Okay, everybody got that? Perfect. And this is courtesy of our National Ice and Snow Center. Anyone can get this video if they wish. Okay. So in addition to this constant, think about it as a piece of styrofoam floating on, heavy styrofoam, but floating on currents. In addition to this constant movement, the sea ice also undergoes, in the Arctic, undergoes a seasonal melt. So if you look at the ice extent, and in purple in this image is ice, and black is open water, what you see is that in winter, 15 March is the peak of ice. You can see that the ice extends all the way into the Bering Sea, past Greenland, etc. And then in the summer of 1990, the ice pulls back away from most of the shoreline across the Arctic. And then next winter, it freezes again, and thaws and freezes. Polar bears, the icon species of the Arctic, really use sea ice as their habitat. In most of the year, from November to June, those times where the ice is most extensive across the Arctic, all bears use this habitat. The exception is a select number of females that are pregnant and are denning. Sometimes most of them den on the ice, but sometimes some females den on shore. And then they're basically not walking around on shore, they're in a den. Most bears, except for those few pregnant females, actively use the sea ice habitat. In summer, when the ice pulls away from the shoreline, basically July through October, the ice is at a minimum. Most polar bears in the Arctic basin, about 90% of all individuals in all the Arctic basin, move with the ice. So they drift away from shore with the ice. Few places, and the lady I spoke with last night that went to Churchill, yes, hi. In Hudson Bay is one place, Fox Basin is another. When the ice pulls so far away from shore, all the bears spend the summer on shore, where you can see them from tundra buggies. But most of the bears in other places in the Arctic actually follow the sea ice into the Arctic basin. A few individuals similarly stay on shore. And on shore, bears don't have much to do. They don't have anything to eat, so they basically are mostly inactive. Why do polar bears use the sea ice as their habitat? Because polar bears are specialized seal predators. If you look at the diet of polar bears, you would see that bearded and ringed seals compose the majority of their diet, especially ringed seals. And the way the polar bears hunt those seals is by ambushing them next to their breathing holes. So a polar bear would sit at a hole waiting for a seal to come, and when the seal surfaces to get a breath of air, okay, this is what a polar bear is looking for, is this seal coming up, the bear grabs it and pulls it out and eats it. So this is a live ring seals, this is a dead ring seal. Polar bears occasionally can get bearded seals, and they're very large and beneficial prey. And most adult polar bears usually only eat the blubber, the fat layer of the seal. Okay, so you can see, if you fly in a helicopter and you see a carcass, this is what you will see. Mostly the muscles are left, but the fat is eaten. Colleagues of mine, Ian Sterling, largely Ian has been studying polar bears for 45 years. He works for the Canadian Fish and Wildlife Service and has studied polar bears all his entire life. Basically estimated that a polar bear every year would need to eat 29 seals if they ate the whole carcass, or if they only ate the blubber, such as this, in this case, they need to catch and kill 36 seals, every adult polar bear. It turns out that if you're a polar bear walking and hunting on the sea ice, most of the year you're not going to find many seals, because seals come up to the surface of the sea ice largely in April, May, and June, a little bit in July. And the rest of the year, they are mostly pelagic. They swim under the ice. They come occasionally for a breath of air, but they don't spend much time on the surface of the ice. So they're not accessible. Except that in spring, which is why they spend more time on the surface, in spring these seals give birth to their young. And what you see in these set of pictures is a newborn ringed seal pup. They're white. And you know that the Canadians used to club them down and because of the fur. But anyway, the mother seal builds a lair under the snow over the ice, creating a snow cave. And then she gives birth in there, and she comes occasionally and nurses the pup in the lair. This is what it looks like when a polar bear pounced on the lair, and now the seal pup is exposed to the polar bear. And this is what happens to that seal pup when it is the polar bear finishes off the job. And the adult seals are especially available in spring because that's when they tend to the pups. But also, not just in spring, but over what we call the continental shelf. And what you see here is an image of the coast of the Yukon and Alaska and a little bit of Russia. In blue, you see the Arctic Ocean that is deeper than 200 meters. And you see that most of the Arctic Ocean is very deep. It's a deep ocean. And the continental shelf, which is what we define as a 200-meter bathymetry, is especially narrow in Alaska. It's wider in the Chukchi Sea and the Russian Siberian coast. The seals, turns out, don't venture much into the deep ocean because there is nothing for them to eat there. Most of the primary productivity and secondary productivity in the ocean is over the continental shelf, and I'll tell you in a minute why. And these lines are showing you the seal tracks from satellite tags that have been glued onto the backs of these seals. So these are colleagues from Canada. They put satellite tags on the seals, and they follow them. And you see that seals are mostly found over the continental shelf. Okay? Now, so seals are available mostly in spring because they're pupping and caring for their young. There are more young, naive seals that can be eaten. And most of this activity happens over the continental shelf. An interesting observation is that although polar bears can walk really, really long distances, one of the females that we collared, my students collared in Alaska, actually ended up walking all the way to Greenland, and then she came back. But that's rare. They can do it, but it's rare. We also had one bear that went from northern Russia and crossed all over land to the Bering Sea. Don't know why. They do it. They do weird things. But most of them show what we call high fidelity to specific subpopulations. So if you look at that region that I've talked about a lot so far, which is the Canadian Yukon territory, a little bit of the Northwest Territories, Alaska, and a little bit of Russia, what you see is 3 subpopulations. And the lines show you the 95% of all locations of all bears captured in this region. And you see that in 50% delineations, there is very little overlap between these subpopulations, meaning that animals that we caught in the Beaufort Sea off the coast of Alaska will spend most of their time in the Beaufort Sea. Now I'm going to show you this video again. And now I want you to pay attention to the annual differences. Hello? Here we go. Okay, again, we are looking at the globe from the North Pole White is old ice. Again, please concentrate on this region. You see that the ice doesn't move very far from shore in the 90s. Now start looking at 99. Two 2012 was the lowest ice year on record. Okay, so what you see is that we have been losing sea ice recently at a very, very fast rate. Now what happens, and not only that, but we are losing the old ice. You saw that there was less and less white in those images. If we look at this in a graphic way, this is the trajectory of the ice, the amount of ice or the extent of ice in the Arctic in summer. And you remember that every year the ice melts and then refreezes. So every year you have melt. But how far is the melt? This is the mean and 2 standard deviations of the ice melt every summer. And this is using satellite records from 79 to 2000. And then the 2007 through 12 are shown you here. And you see that they are way below the 2 standard deviation. Okay? The Center for Snow and Ice has readjusted this figure to include all our records. And now they're using 81 to 2010. And you see that the whole mean and standard deviations move down. So we have shifted the baseline. And even when we do that, the last few years, including this year, are at the end of that distribution. And to show you a comparison of 1990, just again, this is images out of that little video. You see much less older ice, and much greater extent of ice melt. Okay? In fact, the news we got this week was that January 2016 was the lowest ice extent in the Arctic Ocean on record for winter, not summer. Okay. Now, what happens, and if you were very quick in watching that video, what you would have seen that this younger, thinner ice, because it's drifting and it's driven by ocean currents and winds, now drifts faster. So if it drifts from here, from east to west along the Alaska coast, it drifts faster. Now, if you remember, polar bears show fidelity to their subpopulation, meaning they're always, if you catch them in the Beaufort, they will be there in the Beaufort most of the time. To stay in the Beaufort, when the ice is drifting to Russia, what do you have to do? You have to walk on a faster, just imagine this was a treadmill, and you increase the speed. What do you have to do? You walk faster. Okay, so we wanted to quantify by how much faster. What does it mean to a polar bear that it has to walk faster? This is how we study polar bears. So we sedate them from helicopters, either launched from an icebreaker or from shore. We sedate them, including the cubs. That's, somebody asked how come I was holding 2 cubs. The mother was sedated, as were the cubs. We collect all kinds of biological samples, and we put GPS satellite collars on them. We slit the collar on their neck so they can easily, if they want, take them off. Okay, so we have deployed over the years multiple collars. The white dots represent where we put collars on polar bears. The colored dots represent the different locations. We separated them to those subpopulations. So we have the Beaufort Sea and the Chukchi Sea subpopulations. We didn't analyze the data for the eastern or northern Beaufort because we didn't have enough samples. And then we correct the bear movement by the ice trajectory. We get the ice data from the Snow and Ice Center, as I showed you the video that they prepared before. And basically, they create these tracks of the sea ice. If you look at the example of a polar bear moving around, always from now on in my presentation, the track of the satellite collar is in gray. The sea ice motion is in blue, and the polar bear, the corrected polar bear movement is in blue. So keep this in mind. You see that we located the bear here, and then we located it here. But what happened was actually that the bear drifted with the ice to here and walked over this way. So we measure the track, the ice, and the bear. And you can see that the ice is mostly moving westward. Sometimes the bears go north, sometimes it goes west, sometimes it goes back east, etc. We analyzed those thousands and thousands of bear records, and this is what we found. In all the images after this one, the older times, before the ice started melting fast, basically 87 to 98 is going to be solid color, and the newer period, 99 to 2013, is transparent or lighter color. And again, ice, the telemetry track, and actually the corrected bear movements. And what you see is that in all cases, between the early period and the later period, there is a huge increase. So the ice increases, the drift increases, the track increases, and the bear increases, both in the Beaufort and in the Chukchi Sea. But we wanted to see that effect of the ice is drifting westward, and the polar bears are to stay in the Beaufort Sea, and Chukchi Sea are going eastward. So we looked at the changes, and indeed what you see is that nowadays the ice is drifting faster westward, and the bears are walking faster eastward. And especially important to note, it happens in the spring months, when the bears have the most seals available, in April, May, June, and a little bit of July. Okay, so we have a much faster drifting ice. Bears have to walk more to compensate for it, and that happens especially in spring when bears are not supposed to be walking. They're supposed to be sitting in ambush and catching seals, right? So we built an energetics model. This is one of my specialties. I work a lot with energetics. And so I, together with my colleagues and my students, we developed this energetics model. Remember that Ian Sterling and his colleague from Norway, Osland, estimated that an adult polar bear, on average a year, to sustain itself, needs to catch 29 seals, or 36 if they only eat the blubber. Here is what a female polar bear in a Chukchi Sea has to catch. nowadays if she has 2 yearlings with her. So interestingly, at the same time that the same time period that Ian Sterling estimated 29 and 36, our model predicts 30 and 37. We couldn't get any better than that. Tells you the model is valid, right? Very close to the estimates from observed data. And then you can see that it is increasing for adult females by a little bit, by 1 to 2 seals. But look at how much a female polar bear that has 2 yearlings with her, or 2 yearlings with her, 2 yearlings with her, she has to kill 85 seals in order to keep these 2 yearlings alive, herself and her 2 yearlings. At the same time, we have less ice overall. And guess what? Polar bears are excellent swimmers, but they have to swim a lot more often and longer distances. And I'm going to show you a little animation here of one of the bears that we've studied. And this bear swam, so we caught her on Point Lonely in Alaska, here where the red circle is. And here she is swimming back to the ice pack. You see daily swims. The multiple dots are multiple observations per day. And you see that that bear swam constantly for 9 days straight. No food, no drink, no rest. Constant swimming for 9 days. And she swam 457 kilometers. Based on her track and what we learned from her radial locations, we went back into our data set, and my colleagues from the USGS were able to show that these types of really long distance swims happen more often. And the consequence of these longer swims is that the cubs can't make it. This particular female, which we ended up recapturing here near Kaktovik about 2 months later, when we first captured her, she had a cub. When we recaptured her, she did not. The cub could not swim for 9 days, 457 kilometers. And as our other data should suggest, she was not a unique case. A lot of polar bears lose their cubs now because of these long distance swims. So let's think about it from, again, body condition. And body condition is basically a simple balance between energy intake and energy expenditure. We already know that polar bears have to expend a lot more energy because of the faster drifting ice and because they swim more, and that's energetically more costly. But can they minimize energy expenditures in other ways? And when animals are facing starvation or food deprivation, they have an alternative. They can go into reduced metabolic state, reduced activity. Here is a prairie dog right there. Oh no, this is an Arctic ground squirrel, I'm sorry. But anyway, animals go into what we call winter hibernation. And it was thought for many, many years, since 1983, that polar bears can get into a physiological state called walking hibernation. They don't do what black bears do, where they go into a den and basically don't move much, but they can do it, the same physiological adaptation of conserving energy while walking. And Nelson et al. Compared polar bear physiology in black bears and polar bears, and they said there was no difference in the physiological. And so polar bears can minimize energy expenditure. And we wanted to test that idea, so we went in and we captured bears in early summer, sampled them, took measurements, and then fitted them with the satellite collars. And then we went back in summer, and some of the bears stayed on shore, some followed the ice, as I showed you before, and then we recaptured them. And this is why we had to use the icebreaker, to get the ones that went all the way north to 80 degrees north. To remind you, we capture them from helicopters. We put the radio satellite tags on them, and from these tags we can get not only the movement rates, but we can get the temperature when they were, external temperature, and activity, how active were they. And these are the results. We just published it in the journal Science this summer. And what you see is that, indeed, polar bears decrease their activity during the summer months, trying to conserve energy. And there is a little less activity on shore early on, but it's not different later in the summer. But it's nothing similar to what actually polar bears themselves do in winter hibernation. So they do save a little bit of energy, but nothing as substantial as polar bears and black bears would do in hibernation. We also looked at another parameters, which is body temperature, and this is from open circles are polar bears, and closed circles are black bears, and this is from work by colleagues that have done it in Alaska. And what you see is that during winter hibernation, when bears consume little oxygen because they are in hibernation, their body temperature declines to these levels. Okay, so all the way down to 31 degrees centigrade. So what we did in the polar bears that we captured and then recaptured is we implanted little tiny temperature loggers in their abdomen. I can tell you that the surgeries were insane because look at us, it's minus 20, probably minus 40 Fahrenheit wind chill, and we are wearing surgical gloves and doing sterile surgery on polar bears. And this is me and my student John Whitman. So we did it, but we did it. People said you couldn't do it, and we did it. Because I'm stubborn. I don't take no for an answer. Okay, so this is what you expect from body temperature if indeed we are talking about winter hibernation. This is what black bears do when they go into hibernation. Start at 37, you drop down to, well, it's 35. I showed you can go down to 31, but we said, okay, 35. And then when you finished with the walking hibernation period, you'll go back to 37. We retrieved those loggers, and this is what we've seen. A slight gradual decline, nothing like walking hibernation. Except this bear here. But you see, it's not summer anymore. This is in November. So what happened with that bear? That bear entered winter hibernation because she was a pregnant female. And what you see in her track, if you don't look at the smooth data, but at the raw data, is that she entered her den and entered hibernation at 35 or a little less and stayed there the whole winter. We caught her the next spring. She had 2 little cubs with her, so we know she was pregnant. So polar bears can conserve a lot of energy by going into hibernation, but only during winter, just like black and brown bears. They cannot, black and brown bears, and now we know polar bears do not employ hibernation physiology in summer. We also tried to find other parameters, so we used all the samples we collected, and what we see is that in bears over the ice, over deep water, and the enzyme alkaline phosphatase is low, such as it is expected in fasting. Another one, non-esterified fatty acids are really high because they're using their own fat stores. Serum albumin, a major blood protein, and glucose. This is the stuff that people, we go to the doctor, they take a blood chemistry panel. These are the variables they're looking at our body condition. And if you were in winter hibernation, albumin will go up. In our polar bears, it goes down. If you are in adaptive fasting, glucose levels don't change. In our polar bears, they went down. So all in all, this tells us that polar bears that stay on the ice and drift faster and walk faster and swim more are in a bad nutritional condition. So we found no signs of walking hibernations. But I was showing you all these figures, and I didn't point to the fact that the bears that were on shore were doing great. Only the bears that followed the ice were in this poor nutritional state. So we wanted to know why. What are the things that happen to shore bears? And what we found is that they eat a lot of whale carcasses. It turns out, and we decipher what they eat from using what is called stable isotope analysis. And you see that this is a typical signature in 3 different tissues of consumption of whale. Where do these whale carcasses come from? Well, they come from us. The native communities along the coast, Barrow, Nuiqsut, Kaktovik, they all harvest bowhead whales as part of their subsistence harvest. And their quota is 27 whales a year. These 3 communities total compose of maybe 5,000 people, so 5,000 people cannot finish eating 27 bowhead whales every year. They leave the carcasses on shore, and the bears aggregate and eat them and actually maintain body condition, which is great. So we have a feeding, in Wyoming we have an elk feeding program, right? The elk feeding grounds. In Alaska they inadvertently have polar bear feeding stations. Big problem. A, increased human polar bear conflicts, and it turns out that the whalers, which are amazing, I've seen them go out in their boats and strike whales, it's unbelievable, but they're not being as successful anymore because in the past the whales were restricted to shore by the heavy ice, and the whales were using the leads, the open leads, and then you put your boat in the open lead and you strike the whale. Now there is expense of open water, big storms, so the whaling is going down. They are less successful, there are less carcasses on shore to support polar bears. So what do we record? What do we see? Well, we see that polar bears' size is shrinking. I mean, they're nutritionally stressed. They don't grow to be as big as they used to. And survival, especially the cubs. Remember, if a female has to kill 85 seals every year, while she has to walk about 9 hours more, 3 hours more, from 6 hours a day to 9 hours a day, okay? She doesn't have time to sit and ambush the seals, so she has to hunt more seals with less time. So what we see is extremely low cub survival. Of the 80 polar bear cubs, the cute cuddly cubs that we tracked between 2004 and 2007, only 2 survived. 2 of 80. So these 2 cute bears that are in my picture here and I love dearly are gone. And the 2 bear cubs that John Whitman is hugging here are gone, and many, many more. And when you don't have recruitment, when you don't have cubs growing to adulthood and joining the population, your population declines. So what should we do? Turns out that we can do a lot, because sea ice loss has been unequivocally linked to global warming, and all the models that have been carried by my colleagues show that if we reduce greenhouse gases, we can stop sea ice loss. So this is ice loss, unmitigated ice loss, unmitigated global warming, meaning we'll have no ice in the Arctic not too far into the future, okay? But if we follow the global commitment for 2020, we can stop that. We can reverse the trend. And luckily it is because of this seasonal pattern of melting and refreezing. The sea ice will refreeze if we stop global warming. And if the ice is there, there will be polar bears there. So there is a lot we can do. And in fact, a lot of the papers you guys may have read in Laramie Boomerang, letters to the editors of me writing about, we need to combat, that's why I'm trying to send the message across. We can do it. We can do it. We just need to do it. Obviously, this has been a tremendous amount of work. I want to point to some of my collaborators. Steve Amstrup worked on polar bears for 35 years with the USGS in Alaska. Hank Harlow, a good colleague of mine from the University of Wyoming, a very good close friend. My 3 PhD students working on the project, George Derner, Eric Regil, and John Whitman. Multiple colleagues and helpers from all kinds of agencies. Helicopter pilots, Howard, Chuck, Doug, Joe. Paula, who used to be Paul, Bill, and Mel. Could not have done any of this work without their help. And of course, our data and funding sources, again, and photo credits. All this could not have been done with contributions from NSF and USGS and Fish and Wildlife Service and the University of Wyoming, being very generous. And if you have any questions, I'll be happy to answer.
Thank you very much. Are there questions or comments?
Yes?
This doesn't, it's not exactly about polar bears, but it's sort of a side to it. Are we losing tundra as well? Has anybody thought about that?
Yes, we are losing tundra. What is happening, actually, the tundra is our biggest threat at the moment, because the tundra was a lot of organic material that is frozen in what we call the permafrost and held a lot of carbon in it. Now that the permafrost is melting, the permafrost used to be about half a meter below the surface, now it's about a meter below the surface. We have a lot of vegetation that is basically decomposing and releasing more CO2 into the air. So right now the tundra, yes, the changes, we are losing a lot of lakes that were important for waterfowl up north, all over the tundra and the boreal forest, because they are draining down, and a lot of organic matter decomposing.
So there is a Northwest Passage now.
There is a Northwest Passage. In fact, 2 years ago, a Norwegian tourist ship went all the way around the Arctic. There is a Northwest Passage. In fact, one of the things that I'm involved in is looking at shipping lanes and how should shipping lanes be managed to prevent polar bear decline. Because you can imagine, boats and tourists, just like we have in Antarctica for penguins and stuff. Now there is a lot of discussion about that in Arctic for polar bears conservation. Yes?
I was wondering, you probably had this number in your presentation somewhere, but it didn't catch my eye. What's the percentage of polar bears who stay on shore in summer versus the percentage who follow the ice? And is that changing?
Right, yes, definitely so. So I mentioned it verbally, but it wasn't on the slide, so it's probably was missed. Until recently, except for Hudson Bay and Fox Basin, where all the ice is gone totally, and all those bears from those subpopulations go to shore because they don't have a choice. So Hudson Bay and Fox Basin, all the bears go on shore. In the rest of the Arctic, about 90% of all polar bears stay on the ice because evolutionarily they're cued because they don't go into hibernation. They're still active. They're active all year round unless you're a pregnant female in a den. They were trying to keep feeding. In fact, we have, I didn't show you, but we have data on an enzyme called, or a hormone called ghrelin, which initiates foraging. It's really, really high in these bears. They're still trying to find seals. So 90% of all global population, except Hudson Bay and Fox Basin, follow the ice. Only 10% in Chukchi and Beaufort and Svalbard go to shore. So a very small part of the population. However, because so far, at least in the Beaufort Sea, because the females that come to shore and feed can keep their young, there is a cultural transmission of this behavior. So more and more polar bears stay on shore. The number of bears staying on shore is increasing. Yes, so we are seeing an evolutionary change through cultural transmission, but because of high survival of shore bears compared to ice bears. Yes. Yes.
How's the seal population?
Good question. You will be surprised how little we know about seals compared to polar bears. Ice seals are extremely difficult to study. And very few people manage to trap and put collars and track them because they, most of the time, are under the ice. In fact, a very good colleague of mine, Brendan Kelly, I think one of the figures was from his work, trained a dog, a Labrador retriever, to sniff out those layers of the ring seals when the pups were in there. But instead of like a polar bear pouncing on it and killing the pup, he used that to actually capture the seals and the mothers and put tags on them. Because it's really, really difficult to get those seals. And so we know very little about seals. We do know that there was a huge rainstorm in the Banks Island area. I think it was in 2011? Yes, 2011. It was so warm that in spring it started raining and all these layers melted and all these seal pups were just sitting there on the ice. Many of them died. Many of them were eaten by polar bears because they had no cover. It was a huge disaster. You can imagine that with less ice, earlier melt in spring, the seals, the pups don't have enough time to mature. Okay, they are losing their little layer. So yes, we are expecting, based on the less than desirable level of knowledge, but based on what we do know, we expect them to crash. Having said that, harbor seals are moving into the Arctic from the Pacific because it's now they can live there. So we have a lot of new things coming up. And maybe polar bears will be okay eating harbor seals. I don't know. Harbor seals don't have as much blubber as ice seals, but they're pretty fat. I worked on harbor seals in Glacier Bay, so and they can get big too. So who knows? It's we are in a fascinating period of change. A lot of it is not very good, but yeah.
Do you get protein from blubber?
No. Blubber is mostly fat, and polar bears put a lot of fat on. It's their main energy store, but they do eat enough of the seal carcass to get protein, especially the pregnant females and the growing. So what happens is if a big male polar bear in good condition killed a seal like that and ate only the blubber and the carcass is sitting on the ice, young growing polar bears, subadults and juveniles, will come and finish it off and eat a lot of the protein that they need to grow. And also Arctic foxes. The biggest surprise I had was seeing Arctic foxes all the way up to 80 degrees north. It was unbelievable that they make it. How do they survive? We don't know, but they do. Mostly scavenging after polar bears, but in the Arctic basin there is very little to eat. So I don't know, but it's fascinating.
So thank you very much.